So, good morning, everyone, and good morning, new person in the room. My name is Sofia Larsson, and I'm a software developer and the digital sustainability competence lead at a consultancy called 1337. I also co-host the Swedish podcast Developers together with my dear friend Madeleine Schöneman. And I have always had a passion for sustainability, like many others, I think. I have been worried about the effect that we humans have on the environment. And so, because I've heard these things, like that in the past 40 years, we have seen a 60% decline in the populations of mammals, birds, fish, reptiles, amphibians, with over half of all insects gone since the 70s. This really worries me and it makes me really sad. But for a long time, I felt so lucky to be in the digital industry, which I thought was like inherently environmentally friendly. But it wasn't until I learned about the environmental impact of digital products and services that I fully understood my impact as a software professional. I was, of course, shocked to learn that the products that I help create may have a bad environmental impact. But that realization also sparked a new purpose in my work, transforming my climate anxiety into action. And today I want to share with you how software contributes to climate change, but also what we can do about it with the tools that we already have. The talk is divided into 3 sections. In the first section, climate science-ish, I will talk about the environmental impact of our industry. And in the second section, carbon in our code, I will show you some real-life examples of like everyday applications that contribute to climate change. And in the final section, what can we do? We'll look at concrete solutions and actions that we can take with us to start addressing climate change. So, have you ever heard of the Jevons paradox? Okay, so it's a phenomenon named after the 19th century economist called William Stanley Jevons. And in 1865, Jevons observed that when England introduced a new type of steam engine, the Watt steam engine, England's use of coal skyrocketed. So he argued that, contrary to common intuition, when we make improvements that increase efficiency, they often result in increased consumption of the resource rather than decreased consumption. And this is known by, like, this is the most famous rule in environmental economics. And economists have known this for a long time. This is how economies and businesses grow. So, like, why even call it a paradox? I think it's because it fools us every time. As software professionals, I think that we tend to think that our work does not contribute to any like immediate environmental impact because the code we produce doesn't create carbon emissions. But the digital industry as a whole is responsible for a significant amount of carbon emissions. As data centers are becoming more and more energy efficient, we're storing and processing and transmitting more data than ever before. The demand for computing power is growing at an exponential rate. So data centers account for 2% of all global emissions. This is about the same size that the aviation industry. And the aviation sector is often like cast as the villain in the fight against climate change, We have a word for it in Swedish, flygskam. It translates to flight shame. So we shame people about flying, but we don't shame people for watching Netflix or building Netflix. And if the internet was a country, it would be the 6th largest polluter in the world. And some like to call the internet the world's largest coal-powered machine. And I think it becomes clear when you start to consider how electricity is produced. Since the Industrial Revolution, fossil fuels have been dominating the global electricity generation. And this chart is from 2021. We haven't gotten the results for last year yet, but it probably looks about the same. So you can see here that fossil fuels make up for 62% of all electricity. And if you would guess, which source of electricity do you think is the fastest growing one today? It has been the fastest growing one for the last couple of years. It's coal. In 2021, coal rose to a new all-time high record. It rose by 8%. It was the biggest rise since at least 1985. The whole electricity sector rose to a new all-time high regarding fossil fuel emissions. And if we want to be on the pathway to keeping global warming beneath 1.5 degrees, coal has to drop with 2/3 in this decade. But I also want to point out a highlight here. For the first year ever, we have had renewables like wind and solar power making up for 10% of global electricity generation. But it's too slow. So my point is that the energy sources that power our industry may come in a variety of different forms. And they often come as a mix. This is known as carbon intensity. And we can look at how carbon intensity looks in the world by using this map called electricity map. This map shows real-time data of the carbon footprint of energy production in different regions and how it varies throughout the day. It's clear from the map that some areas, such as Poland, have a much higher carbon intensity due to their reliance on coal-fired energy. Like 80% of their electricity comes from coal. Meanwhile, countries like Sweden have a mix of hydro, wind, and nuclear power. They have a much lower carbon intensity. And France has a lot of nuclear energy. It's low carbon, but it's not a renewable source. So as software professionals, we can think about where and maybe also when we use our electricity. And we can try to choose data centers in low carbon regions to help promote the use of renewable energy and have low carbon footprint from our applications. So now let's move on and look at some of the stuff that is driving these emissions.
Quick question.
Yeah?
I noticed that Ireland was pretty dark.
Yes.
That has a lot of our data centers.
Yeah, Azure North Europe is there.
As well, AWS as well. Have you made any sort of, if you would make a quick recommendation of what the data centers that are like verbal webs constraints like should reside inside the EU or if you can choose it globally?
Yeah, so if you use Azure, you can use, I think it's like West Europe instead. It's in the Netherlands, it's lower carbon there. But yeah, it would be nice if we could use Sweden's. But that's the one I would choose in Europe. Thanks for the question. But yeah, so you might have noticed that web pages are getting bigger with each year, but we barely notice it because Our phones and our networks have become so much faster, so we tend to rely on it. But the median desktop page has become 3 times larger now than it was 10 years ago. And the same goes for mobile pages. The median mobile page is nearly 7 times bigger than it was 10 years ago. As you can see here in the page weight breakdown, images and JavaScript are getting heavier with each year. So images alone make up for 44% of the total weight of a typical desktop web page, and JavaScript makes up for 23%. And this is what I find most interesting. There's a trend of serving fewer images on web pages. So back in 2012, the median page served 42 images, whereas today the median page serves 25 images. And it may seem like a positive step towards reducing page weight and saving carbon, but look at this. Despite serving fewer images, the combined size of the images being served today has increased threefold compared to 10 years ago. And we can see the same trend with mobile pages. The number of requests is the same as 10 years ago, 23. But the image size has increased 6 times. So we're using fewer images, but they are larger in size. And I guess that the trend is that maybe there's a lack of attention to detail, and many of us, as I said, have started to rely on fast internet and devices, but this can actually lead to bad user experience and a surprisingly big carbon footprint. So I will show you how you can perform a sustainability audit of a web page. You can start by going to this site, websitecarbon.com. Website Carbon is a tool to roughly estimate the carbon footprint of any web page. So I'll search for Svetug's page. Uh-oh. This web page is dirtier than 92% of web pages tested. 2.5 grams of CO2 is produced every time someone visits the page. You can imagine, like 2 grams every time. But this web page appears to be running on sustainable energy. That's good. And over a year with 10,000 monthly page views, Svetug produces, and I think the one down here is the most relevant. So almost 800 kilowatt hours of energy. That's enough electricity to drive an electric car, almost 5,000 kilometers. I think it's like to the southern Spain or south of Portugal, maybe. That's pretty far. So, can you guess what might be the issue here? The image? Image. Yeah. My first thought was also to check out the size of the image, especially the big one.
Like the small images are too high fidelity.
Could be that. Yeah, there's a lot of them. Let's see. I don't know how to use short commands on Mac. I use Windows when I work. Okay, so let's look at this image. This image is 1.7 megabytes. It's large. And I don't think I need that level of detail to understand how fun it is to be at Svetug. And it's very high res. And you can see the image format is JPEG. And some of you may know that there are other image formats that we could use. But you mentioned the avatars. So let's look at those. And I looked at Madeleine here. And her image is it's fine. It's small, like 46 kilobytes, and it's pretty small in size. It could be smaller, but I think this is fine. Then I looked through some more because I think like this is a big carbon footprint for a small page like this. There has to be something else. Is Johnny here? No, he isn't here. Then this is fine. Let's look at Johnny's page. So his image is 2 megabytes. And look at the size of the image. And there are a couple of more images like this. So maybe, I'm sorry, you did a great job, but maybe someone was in a stress to add some more images and didn't resize them. And I think we all do this sometimes. We forget. So what I usually do is when I like to guess first, and then I go to Google Page Speed Insights tool. This will help me call out what parts of the page that are slowing it down. And we can see here that it warns about the image of Johnny. Yeah, there it is at the top. So it's the largest image. And it also says that we can use images with a more modern image format like AVIF or WebP. I'm sorry, this is in Swedish. I missed that. But it says, oh, you can use WebP and AVIF. It's better compression than PNG and JPEG. And I think that a good rule of thumb is anything that is above like 500 kilobytes should be compressed or resized. Okay. So how many of you have heard of ChatGPT? Okay, good. Then I don't have to explain this. So training an AI model is an energy-consuming process. And a team of researchers wanted to find out how carbon-intensive it could be. They used an NLP, a natural language processing model, which is often used in search engines to get like relevant results, or in smart assistants like Siri or Alexa. And they didn't want to measure this in grams or like tons of CO2 because that's kind of hard to, it's not tangible. So they compared it to the emissions from an average car, including the emissions from production and all the fuel that it would use during its lifetime. So 57 tons of CO2. And they went on and trained this model for 3.5 days. It produced 284 tons of CO2. Is anyone a quick counter? How many cars is that? 5 cars. Training an AI model for 3.5 days emitted as much CO2 as 5 cars during their entire lifetime. I mean, this is a heavy carbon footprint. Just imagine if we were to start training more AI models. So if you haven't been living under a rock, you probably have heard about OpenAI's latest product, ChatGPT. When ChatGPT was released, I was of course curious about its carbon footprint. So I asked ChatGPT. But the data is not publicly available. We don't know how many users it has. We don't know how much energy it consumes. If you asked ChatGPT about its environmental impact 2 months ago, it would say, I'm a large language model trained by OpenAI. I don't have any physical presence or environmental impact. I exist solely as a collection of algorithms and data stored on a network of computers, and I do not consume any resources or produce any waste or pollution. The model had a very singular way of thinking about itself. So I asked it again. This is me asking it last week. And the answer has gotten better. It says that its energy consumption contributes to greenhouse gas emissions and it has a negative impact on the environment. But it still doesn't say how much. I also asked it if it like if it would guess, is the model larger than Apple's Siri? And it says that it's fair to assume that it is. But it's not only the training of the model that is energy consuming, it's also about storing all that data somewhere. But yeah, we still don't know how much, so we have to resort to guessing for now. And I won't share any of the guesstimates on stage, but if you want to, we can talk about it afterwards off stage.
I think if we ask ChatGPT is 4% because it answers.
It answers this week. Now it answers. Okay. Is it like per day or per request? Interesting. We will all ask it later, I think. Ken. Thanks for sharing that. Okay, so let's move on and look at what we can do. And let's do like the bottom down approach, starting with the front end and move towards the back end. There's a quite famous principle called the Pareto principle, but it's also called the 80-20 rule. It basically states that 80% of what you do results in 80% of your results. And this rule can be applied to like everything in life. Like this one, I'm willing to bet that most of you wear 20% of all your clothes 80% of the time. No. Or like in a social situation, if we started to mingle now, I bet that 20% of the talking would be done by 80% of the talking would be done by 20% of the people in the room. So some here are really chatty. But you get the idea, and the principle can also be applied to many things in software development. One of them is that, like with nearly every application, 80% of users only use 20% of software features. I think this is the most important step. Sure, it's like boring, but the most carbon efficient feature is the one that doesn't exist. So like start by removing features that no one uses and really focus on the MVP and really do your research. Like who is this for? Who's going to use it? Why? But if the feature is about, yeah?
Could you clarify what is the carbon footprint of a feature that is implemented but not used?
That depends on the feature. Like if it's something spinning on the server all day long, waiting for someone to, or the carbon or the carbon footprint of maintaining it, like having people maintaining it year after year. It's hard to give an estimate. But yeah, if the feature is about adding dark mode, you should say yes. Google developers did a research on this about how much various colors tax the battery life, and they found that using dark mode used 30 to 65% less power than light mode. For example, if you used Google Maps in dark mode, it used 73% less of the battery compared with light mode. Yes, I will let you take a picture. But you will want to take a picture again. Also, that blue color uses 25% more power than green or red. So you can actually save battery life just by choosing energy efficient palettes. It doesn't have to be all like black, but it could be dark yellow, dark green. You get the idea. This only works on OLED screens, but newer devices like this, my Mac, iPhones have it. And I think there will always be people who prefer one or the other. So you could cater for a better user experience by offering both, but maybe you could default to dark. And we saw how the size of images had tripled in 10 years. Images are real carbon bloaters. They are the most used resource on the web. And what we can do about this is, first of all, remove any unnecessary images that don't add to the user's experience. And resize the images. You don't need to upload a large image just to use it in an avatar. I think we often do that mistake. I do, definitely. And we can optimize the ones that we already have. JPEG and PNG is great, but there are newer image formats like AVIF and WebP. WebP and AVIF can compress better than most formats. AVIF can get up to like a tenth of a JPEG. And WebP is great because it's supported in all browsers except Internet Explorer. But we don't care about Internet Explorer. You can use this app called Scoosh to visually compare the difference and resize and compress the images. So I'll just show you how. In my test, I'm using the Scoosh app to compress and visually compare the header image from the Svetug homepage. The original image is 1.7 megabytes, and I will compress it with WebP. And as you can see, I'm not even resizing the image, which I probably should, especially if it was one of those avatars. Now we can see that it has been compressed down to 143 kilobytes, and I can barely spot the difference. You can see, like, this guy's hair is a bit blurred, but seeing his hairline in high res doesn't add to my user experience. And it's like this for most images, right? We don't need to see the details. We just need to get a feeling of the product. So yeah, this makes a huge difference. Imagine if we would do this to all the images on Svetug's page, and especially the avatars, and resize them. It would make a huge difference to the performance and the carbon footprint. Now let's move further down and look at caching as a way of reducing carbon emissions. Caching is a pretty simple but very effective technique. You want to reduce the number of requests to the server and also the distance between the client and the server. The closest we can get to the client is by using local caching. This means that we store data on the user's own device. They fetch the content once, and then whenever they need it again, they already have it there. But this is only helpful for one user. So if you have users making the same requests, which they often do, you don't want to go down to your database, sort something, fetch it again. And so you could consider using something like a remote cache. It's called a reverse proxy. A reverse proxy sits between the client and the server. It can handle requests for you, and it keeps a copy of the assets. So any future request that is like the same as the previous can be served instantly without having to go to your server and down to the database and do the processing all over again. And remote caching is also very effective because you can compress the HTTP response, so it gets even smaller. If you have users all over the world like this, you still want to do something about the distance between the server and the client. Because the further your request has to travel, the more carbon emissions we get. So you can use something that is called a content delivery network, a CDN, like Cloudflare. A content delivery network is basically like a reverse proxy, but it's on a bigger scale. So it's a network of servers that work together to distribute your site all over the world. So the content will load faster and it will be more energy efficient. And when it comes to servers and architecture, I really like the principles of the 3 R's. We can basically optimize it in 3 ways: relocation, right sizing, re-architecting. This is my favorite one, relocation, because it's a real low-hanging fruit, but it can have a huge impact. We talked about how different regions have different carbon intensity profiles, and we can think about this when we choose where to host our stuff. And if you have used any like big cloud provider at least, you know that choosing where to host your stuff is just a drop-down list. It's one click away. And I really like this example from Google Cloud Platform here. They display a green leaf where the energy is more, greener. But you can look up these lists, like if you're using Azure or AWS, to choose the greenest region. And right sizing, it's about perfectly meeting demand. So if you know how your application is used, like when, you can, you need to know that first, of course, but this is like how it looks for my team. Our users only use our app during work days. So this is what it might look like during a 7-day week. And this is what it might look like on a weekday. They sleep at night, most of them, and then they work, and then they take lunch, and then it drops. They pick up their kids at 3 and stuff. So you wouldn't want to run servers here, and in this previous one, all day long, idling. It's just wasteful during holidays, lunchtime. So what is our best option to right size here? Do you have any suggestions? Something that perfectly meets this. Yes.
Some kind of function as a service.
Yes. Yeah, so using functions. It's I guess it's still fairly new computing model. How many of you have had the chance to try it out? Yeah, so many of you. And many cloud providers have this feature. You have Google Cloud Functions, Lambdas in AWS, Azure Functions in Azure. They can automatically scale and they can save you money, and they save you the energy of having to care about the underlying implementation. And the third one is re-architecting. It's basically about choosing machines that suit your workloads and using a cloud provider that offers green hosting. So the first thing you can do is just by migrating to the cloud, you will save carbon. Because hyperscale cloud providers, they are usually so much more effective than small ones, generally. This means that you could reduce energy consumption just by moving to the cloud. And also run serverless. I know that some don't like it because I think that at least when I use Azure, it feels like it's not fully developed yet sometimes, and the documentation sucks. But you will have automatic scaling, you will have reduced costs, and you will have so much many developers can use them without having to know stuff about infrastructure. I think they're great. And also, if you run batch jobs, you can run them where the electricity is green. Generally during nighttime or in colder regions, You can also use Cloudflare's green computing service, which they schedule these batch jobs for you so that they are run where the energy is renewable. So, in conclusion, we don't have to give up on creating amazing products. It's not like fight shaming that you should stop doing everything. But we need to understand that we can't like make everything efficient and solve it with that. We saw in the Jevons paradox that that doesn't work. We just use more. So we can focus on the basics of design and coding and architecture. Like go back to your textbooks and make it really perfect and efficient. So yeah, and I think that if we do that, like everything we do has a carbon footprint. We can't avoid that. But if we do it like really, I don't know, perfect and efficient, we can at least extract the most value from each gram of CO2. And just small changes to our work can have a really big impact, as you saw, like by just choosing where to host or resizing an image. And I think that you will feel really proud next time you resize an image, or like, yeah, we should pick that server instead because it's renewable, you know. So yeah, thank you so much for your time and attention. Do you have any questions? I will not pick you first. Yes.
Nobody's going to like this suggestion.
No.
Developers should be those who have the oldest and slowest computer in the room. That way, they will develop optimized applications, and everybody will need slower and less powerful devices.
I think you have a point. And you have a point also, like when we look at data centers or anything like this, 80% comes from 80% of the carbon footprint comes from production of the device. So we should really try to keep our stuff longer. I know it's easy, like when you work for a company and you get a computer every second year, but try to use your like longer. Good suggestion.
I think this is something that can be pitched to different companies. I started in a new company and I actually got a computer that was in use from before. I didn't get a new one because they have a policy on reusing the PC if it's still young. So this is something that can.
How did you feel when you got an old computer?
I've seen this before in a new company. I had in my previous company I was working for almost 8 years and I haven't changed the PC out of principle because it was doing the job, but I didn't want to buy a new one and contribute to buying more every time. But many others did. But here they just like, yeah, that was used like for a year or so. So you can get that. I was really impressed about the awareness on that. So this is something that more companies should adopt.
Yeah. Yeah, it's about like right sizing, right? Use what you need. When you need a faster computer, okay, that's fine. You had a question. Okay.
Yeah, going from running on a server to serverless is very hard, but scaling down, like having fewer instances. I think you're missing that step. Should be there because that will also do something you can do today. Serverless will make you maybe once a year.
Yeah. Yeah, I wanted to do that slide actually. That's a very valid point. Like instead of meeting the demand perfectly like this, like of course you could like build this up like with small chunks of like machines, but it doesn't meet the demand perfectly. Still, you would still like need a server up and running when the requests fall. I don't have the slide for that. I have it like on my other computer, but yeah, it's a great step in between. There is. I think that many of you have seen this image circulating around about like the most energy efficient languages. Have you? Some of you, yeah. I don't think that matters as much as choosing where to host your site. Or like if JavaScript makes you develop something faster, maybe it's better than trying to write it in like assembly code. Yeah. But yeah, it's the small things.
Remember to minimize your JavaScript files.
Yes. Yes. Minimize everything. Yes, David.
Yes, I have a question. About the size, I was thinking like, so we're saying that the transportation of the images or the actual size is the major problem. And then we are talking about maybe using a different compression algorithm. Depending on the compression algorithm, some of them are heavier than others. Let's say we are using Groppe compression over gzip compression, for example, transporting over HTTP. And some of these are much heavier to decode. And the same would be that we're saying that images are a bigger chunk of stuff transported over the internet, but JavaScript to decode, interpret, and run it through the V8 engine, etc., is pretty damn heavy. So maybe a smaller amount of JavaScript has a much bigger impact than a large image.
Mm-hmm.
Is that correct?
I don't have an answer to that. But I know that you are very good at performance, so maybe it's something you should dig into. But this is why I'm giving you like I don't deep dive into anything. I just want to plant the seeds because you are the professionals. You know how to make things efficient already. I just wanted you to know that those things can have a huge impact. Yes, Madeleine.
It's not a question, but a reflection I had, which I found interesting. I haven't thought about this before, despite seeing this presentation a number of times. But the carbon emission website that he used to measure was made with blue colors everywhere.
Hmm.
And blue produces, what was it, 25% more energy?
Mm.
I think you should make a pull request to them.
Yeah.
Green or something, or red, which was more efficient.
Yeah, so I don't know if you heard what Madeleine said. She said that website Carbon webpage used blue color, which uses more energy than green or red. I thought about that as well, but my guess is that it's very dark blue, so maybe it doesn't use as much. So yeah, you if you really like blue, you should use blue.
Check that site on that site and see what the results it will give for itself.
Yeah, and maybe there's also a difference in like blue versus blue. If you have more red in the blue color, it's more like purple blue. It's more energy efficient. I guess it works like that. Mm. Mhm. Okay, so maybe if there is anything more, we can talk about it afterwards.